Recording. It's okay. This is today. So I will be introducing lesson 4, and we've seen the end of lesson 3. Lesson 3 was quite extensive. It was detailed. So we saw what was Ethereum and the differences between Web 2 and Web 3. We also talked about limitation of Web3 and the different things, that is the EVM, ETH, nodes. And also we talked about the risks involved in blockchain, and also the types of networks that are involved in the Ethereum network, and the work of different Ethereum networks. We also talked about risks, that the vulnerabilities in smart contract and also the network itself, and how they have been able to mitigate those problems. So on lesson 4, we will talk more about cryptography and wallets. So cryptography, actually, this is how blockchain secures most of this is cryptography is what actually is kind of the core feature of blockchain technology itself, and it's where cryptocurrency, or the word crypto is actually the full name of cryptography. It's encrypted or cryptographic currencies, and cryptography, or the birth of cryptography, did not start yesterday or in 2008. It started way back during the medieval time, and also during the Cold War, and also the First World War and the Second World War. So there was extensive use of cryptography. So cryptography generally means that it's a way to conceal information or to hide information. It's a way that you can be able to hide your information so that another party does not know. Generally, we have seen people do send letters. In those days, people used to send letters, and there was a way people would write. So some people would write using a lead pen, meaning that these people meaning that the person who was writing that particular letter is angry. That's a code. It's a coded word using different chorus to like send a message, and that's a form of cryptography. So if I'm new to what you're writing, I wouldn't know whether, I will just say that this person maybe lacked a pen, and they wrote with a red pen, but to the reader, they will be able to know that this person is angry. Then we had reversal of words, whereby like the word, let me just show, like this sentence could be reversed to introduction, to wallets, cryptography, to introduction. So people would reverse these words, and then they would give you a decipher. A decipher is something that you can use to like decode the code. So like the first word, normally they would have like a code. So I normally start my sentence from backwards. So it's up to you as a reader to know that the person who you are communicating with starts his or her sentence from backwards. So you have to rearrange these words so that they make sense to you as the person who is decoding this information. So that was the earliest form of decoding or sending signal. Also in African societies, people used smoke signal to convey different messages. So maybe there could be like a big fire, meaning that there is danger coming, or two consecutive smoke clouds. The first one, the second one, meaning maybe a child has been born. So those are the types of signals and cryptographic messages that were being used in those days. So cryptography is something that people have always used, even in the languages themselves, young people always tend to come up with their own languages, like Sheng, slang itself, whereby they change the words to mean they change the words. They normally change the words, and Node fella wouldn't be able to know what these young men are talking about. So that's the art of cryptography. And when it comes to blockchain, it means that cryptography is a method of developing techniques or protocol to prevent a third party from accessing and gaining knowledge of that data from the private messages during a communication process. So cryptography is also made up of two ancient Greek terms, that is cryptos and graphene. The former term meaning hidden, and the latter being to light. There are several terms related to cryptography, which are stated as follows. So when it comes to blockchain cryptography, is also defined as a use of mathematical expression and algorithms to hide and conceal information. And there are two things that you need, not two, but four things that you really need to understand when it comes to cryptography. And the first one is encryption. Encryption is the process of converting that text, the text that you want to be hidden, to a cipher text, a random sequence of bits. It can be ones and zeros, like don't know if you can be able to see my notes here. So we can say like bits or just the name tricky. So tricky can be represented as this 2 3, just some random text like that. So this would be the encryption. This could be the encryption. So if I have this text and I have a decoder, so this one is encrypted and encrypted, and then we have a decoder or decryption. So decryption is the process of and is the inverse process of encryption or conversion of the cipher text to plain text. So this would be now I have something that decodes. I have an algorithm or something that can be used to like decode the word. And then if I put the word there like in a text box, and then I try to decipher, then the text should be tricky, should go back to tricky. Yeah. So a good example of encryption techniques used is the MD5 encryption method, which is common to Web 2 and in most browsers, not browsers, but most applications. And then we have cipher, is the mathematical function, i.e. A cryptographic algorithm, which is used to convert plain text to cipher text, and also vice versa. Key is a small amount of information that is required to induce the output of the cryptographic algorithm. So let me show you an example of such encryption and how it's applied. Let's see if I can be able to get the demo. Yep, gotten it. Okay. So let me share the screen. Share. And yeah, so this one is a crypto system demo where you can also take a look at it and do your do a demo on how you can be able to like generate like how you can be able to see how you can generate your own key. So before we get to this demo, let me just introduce, because you can see there is what we have: symmetric key encryption, and yeah. Okay. So we have three types of encryption methods. So to understand cryptography in blockchain, one has to understand the types of cryptography. There are mainly three different ways in which we can perform cryptographic algorithm. And one is symmetric key cryptography. And then we have the second one, asymmetric key cryptography. And then we have the hash function. So in symmetric key cryptography, normally, in this encryption method, we take a single key into application. This common key is used for both the encryption as well as the decryption process. Using a common single key creates a problem of securing, transferring the key between the sender and the receiver. It is also called the secret key cryptography. So this one use common single key. So this one is symmetric. It means that it's a one-way thing, and you can only do one. And this is why it's called the secret key cryptography. And that is where the word secret key or seed phrase come from. And that's why private keys are it's a very powerful mechanism of encryption, because when you encrypt, you don't have you cannot go back. Once you encrypt a private key, you cannot go back. There is no turning back, like there is a way you can decrypt it. No. So we have a symmetric key cryptography. And this encryption method uses a pair of keys: an encryption key and a decryption key, named public key and a private key, respectively. The key pair generated by the algorithm consists of a private key and a unique public key that is generated using the same algorithm. It is also called public key cryptography. And then we have the last one, which is the hash function. So this type of encryption does not make use of keys. It uses a cipher to generate a hash value of a fixed length from the plain text. It's nearly impossible for the context of plain text to be recovered from the cipher text. Yeah, so that is the types of cryptography. And I think now you can, sorry, not that one. You can go to a demo. So in this demo, you can see they have an example. They have given an example of a traditional door locks that uses one key for both locking and unlocking a door. And that is the private key. So encryption uses one key for both encrypting and decrypting a message. So we can follow these steps and see if we can be able to do that. And so the first step is to generate a symmetric key. So we can just write the word key and then generate, which is now 36. That is the key we have. So you and the recipient of your secret message both will use this key. So we can use this key. So long as you have 36, we can always use that one to change or to get the message. So the next step in this demo, what I will do is that I will write the plain text. So this is blockchain class, and then I will use the above key there that is sits. and then I will encrypt using the above key. Oh no, that is not there. Yeah, so this is the key. So this is now the ciphertext of the message. So our message has been encrypted, and we can now move on to the next process. It's to decrypt the message. So we will copy this ciphertext, and then we will paste it there, and then we will use the same key, that is 36, and then we will decrypt our message. So you see, that's how cryptography works. So this message, if I send you this message, you won't be able to know what I kind of meant. But so long as you have the symmetric key, you can be able to decipher and decrypt. Decipher and decrypt is the same. It's another word for decrypting. Okay. Okay. So if I send you this ciphertext message, you won't be able to know what I really meant. But if you have a way to decrypt, you can be able to know. And this is actually how money or how cryptocurrency is encrypted. And yeah, so this is one way that you can do to encrypt. You can also do encryption in your day-to-day life, if you want people not to know your messages. And chat messages like WhatsApp and Telegram do have a way that you can encrypt those messages, and then you have a secure way to share your messages. Yeah, so this is a symmetric cryptography. You can also try it on your free time, and you share it with your friend. It's a cool way. Yeah. So for practice, you can do what they have actually said. You can generate a symmetric key and share it with your friend using a shared symmetric key. See if you and your friend can send and read short encrypted emails by copying and pasting text with step 2 and 3. So yeah, on our other introduction not introduction, but our other type was asymmetric key cryptography. That is the public key cryptography. So I will generate another key pair of public key and encryption. So a key pair is combination of a public key and a private key. Okay, I think I have. Okay. Let's just continue. So I like the public key as key, and then this one I like it as P key to symbolize private key. And then I'll generate the public key and the private key. So not the figures, they are changing. And then down here we can still write the same message, this message. Can write the plain text there, and then our private key is 105, and then we can encrypt the message. So this, we have encrypted our message. So if I copy this message, I'll do the same down here to see if we can be able to change the message or then decrypt the message. So I liked my public key, which was 54, and then we encryption using recipient public key. So this Okay. Yeah, I've confused. Oh, this is the signed message. Oh, okay, yeah. I'm actually doing the right thing. So we have encrypted it again. We have encrypted the message again. So the first one was encrypting the plain text using the private key, and then encrypting the signed message again using the public key. And this is the ciphertext. So we will copy the ciphertext and then paste it there. And then remember our private key was 105. So 105, let's see if we decrypt the message. So this is the first message, this one, which we had encrypted using the private key. Then we can do the step 2, the same step, and see if it leads back to the original message using the public key that was 54. And then we can, yeah, so we have gotten it back to the original message that we had. So this is how, sorry, I think I asymmetric and symmetric to symmetric and symmetric and asymmetric are two words that normally confuse me, because the second one is what blockchain uses, public key encryption. So this one is the second one, but the, yeah, just to be clear, this one is the one which blockchain uses. Yeah. Yeah. So sorry. So if you can see from step 2, A and B, and 3A and 3B above are not all applied to each message. Instead, you apply the step depending on what you need to do. So when sending a signed message, you can do step 2 and 2B in that order. So you can either do anything. You can choose to encrypt, or you can choose to encrypt the second one, or not to encrypt the second one using the public key. But this one will generally apply to people who are developing smart contract and people who are creating wallets. Yeah, if you are creating a wallet, this is something that you need to like be able to familiar with. But if you are an end user, this kind of encryption are automatically done by the developers. Yeah. Then yeah, so that was the demo for both symmetric and public key. Yeah. So let's go back to cryptography and see now why use or how cryptography is used. So use of cryptography in blockchain. So blockchain make use of two cryptography algorithms. So we have the first one, asymmetric key algorithm, and then we have the hash function. So hash functions are used to provide the functionality of a single view of blockchain to every participant. So blockchains generally use the secure hash algorithm 256 hashing algorithm as their hash functions. So this secure hash algorithm was particularly developed by the NSA, National Security Agency of US. This one actually contributed so much, and also the NASA, the NASA guys also contributed to development of this secure hash algorithm, because they wanted a way that they can be able to secure information and also to, yeah. So this one is a top-notch cryptographic algorithm, and yeah. So cryptography, the asymmetric key cryptography, from what I've explained, is the is where the private key generally needs to be produced by a random number algorithm, and the public key is calculated by executing a irreversible algorithm. So the asymmetric encryption algorithm has the advantage of having separate public and private key, which can be transferred over uncensored channel. So the wallet, from what we learned from the introduction of Ethereum, we have two types of accounts. So the first account is the externally owned account, and we have the contract accounts. So the externally owned accounts is a combination of asymmetric algorithm or public key algorithm cryptography, which will require a public key for interacting, and then you need a private key to access your wallet. So the asymmetric encryption has the advantage of having separate key. It's likely it also has several disadvantages, and some of them being low processing speed and unsatisfactory encryption strength. It is very much necessary to ensure that security of symmetric encryption algorithm during the transmission of data on the blockchain. So one of the major part of asymmetric key cryptography is the digital signatures. So digital signatures provide integrity to the process. They are easily verifiable and cannot be corrupted. They also hold the quality of non-reputation, making them similar to the signatures in the relevant world, or in the real world, that is. The digital signatures ensures that blockchain is valid and the data is verified and correct to hash, correct. Yeah, so from what you have seen, you can easily verify that the information that we encrypted was the best one. It was not the best one, but it was the correct one. And yeah, so hashing, public private key pairs, and the digital signatures together constitute the foundation for the blockchain. These cryptographic features make it possible for blockchain to get securely linked by other blocks, and also ensure the reliability and immutability of the data stored on the block. So back to the first demo that we did on how blockchain secures or validates blocks. So the moment somebody clicks on the button mine, that is when the process of encryption is being done, so that the block becomes validated and encrypted. And you must have the correct information, so that you are able to know that the block is correct. Let me just go back to the 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 let me just go back to the last demo we did on blockchain, so that we can be able to see we can now be able to like understand more about the cryptography or the process of cryptography. So Okay. So this is the Brock demo that we this is the blockchain demo that we did on the other day. So if you go to distributed network or distributed blockchain, so we can try and add new data here on block number 5. Let's say hi, and then we can mine. So this is the mining process, and this is the hash. So the hash is this part. This is the backend process that goes behind this demo, and we have been able to mine. So we can go back to peer 5 or block number 5, and then we add something different, like just some random text, and then we can mine. So that's another block. These are two different blocks now, because they contain different data. And then here we can do the same. So note that I'm using the same letters for recovery words or recovery phrases. Most of them are in small letters. So if you have capital letters when you are doing encryption, that normally changes the hash. So if we were to add a small h here, this will be totally a different hash because they are different letters. But for human readable form, we can actually assume that so we normally our brain assumes a lot. So these two blocks are different. And also this illustrates how, or shows how, if I try to change everything in blockchain, I will have to like change or encrypt data again, all the way from the thousand of the thousand and hundred of thousand nodes which are in the blockchain. And then another thing to also note is that the more we have more nodes connected to the blockchain, the more the blockchain becomes secure. Because for malicious people, or people who with malicious intent to like invalidate the blockchain or invalidate a particular block, they will have to like have access to all those nodes and change all those nodes and change all those chain. So if you can take a look at the hash, the first hash has 4 zeros and 6B. And if you look at the second one, that is peer B, we have 4 zeros and 7B. So this is totally a different hash. And if you can see the peer C, we have the same hash as the one which is in peer A. So you see, that's how you do encryption. That's how data is encrypted in blockchain, and that's how cryptography now uh, plays a big major role, because yeah, every transaction is created that way. Every transaction is hashed that way. So the moment they mine, that's the magic which is happening in the behind the scenes. That is the magic that is happening behind the scene. And this is the we can call it magic. Yeah. So this is the magic. This is how you can do that. Yeah. So that is symmetric, and and the use of asymmetric. So we continue. And yeah, so there are a huge number of application of blockchain technology and
Hello?
Hello, yes.
So when you add data to a block, it changes the hash.
Yeah, exactly.
So if you added data to, let's say, block 2, and we have 5 of them, will that not make the other blocks after that invalid?
Yeah, it will definitely make them invalid, and that's what make it hard for, because if you want to, like, let's say, so if, let's say we add data here in this block, these other blocks will be invalid because they are not sequential. They are not they are not like the previous block will now change, you see. So this hash will change. So this hash zero, the 4 zeros and 12 is the previous hash of this block, you see. So if we change it, let's say we add a h, the hash will definitely change. 0c c3, and then you will also have to change this one. You will also need to change this one, so that this block 3 now has its own hash, because yeah, has its own hash. And then if you change block 3, then you will have to change this other hash. Now remember, this is PIA representing a node in maybe in Australia, a specific node in Australia, with this information linked together. Then we have another node, peer B, maybe a node which is in Africa, in Nairobi, and another one in Nigeria. So peer B, C, D, all that. So if you change in this peer in this node, then you will have to come and change in this peer B, and then also likewise to the other nodes. So it will take you time, and it will be expensive to do that, because it will be it will take you, it will cost you a lot of money to do that. So this is this actually, the more we have more nodes in the blockchain, the more secure the blockchain it becomes. The more the blockchain becomes secure, and the more it becomes even hard to actually corrupt the blockchain. Yeah. So I hope that has answered your question. And yeah.
Hello.
Yes.
Yes.
Yeah, but this method that you just explained is the third method of cryptography,
Mhm.
right?
Yes.
Hash.
Hash.
That is using hash now. That is, after the symmetric and asymmetric method,
Yeah.
the third method is this hash method,
Yeah.
and
The
which to me is more like very if we are planning of doing that, it is very cumbersome and very stressful.
the hash function, or
Yeah, yeah.
yeah. The hash function used in is used deep in blockchain. Like let's see. Don't know if I covered it. Don't know if I covered it. So the hash functions are used to provide the functionality of a single view of the blockchain. Function is mostly used when you want to have a single view of the blockchain, to, like, every person has to have the same information. Like, you want to show people a single view of the blockchain. So, like, currently, right now, if you take a look at this this demo does not actually show the other blocks being invalid or turning to red, or red. But that is because one, I haven't added any data on any of this block. But if I add, they will also change, but they are not somehow connected. And with the hash function, you are able to do that. Another thing is that hash function is I wouldn't say that it's immune to quantum decryption, because yeah, I wouldn't say it's immune to quantum, but it's a high level function. Yeah.
Hello.
Yes.
I think I'm lost somewhere. You say that the hash function is what is used in blockchain.
Yeah, asymmetric, and also the hash functions. Also the hash functions. So
So both of
asymmetric
them are
is,
used.
yeah, both of them are used. So this one, the secure hash 25 seeds is the hash function. Is the example of the hash function. It uses a
Now,
different yes.
let's say an example of MetaMask where you are
Mhm.
given your private keys in form of words.
Mhm.
So which
Yes.
one is that?
So that one is the asymmetric key, because asymmetric key has what we call key pairs. Key pairs, that is the public address, and also the and also the private key. So generally those seed phrase normally looks like this. They normally look like this. They normally look like this. Let me example of seed phrase. So this one is another example of by BIP 39 is the most common standard used for seed phrase hashing. This one actually mainly occurs when you are creating a wallet. You normally use it's a node package or a Java a library of it's a tool that is used to do that. So I'm trying to look for those words. Yeah. So this is an example of seed words, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we encrypt these words, this is the plain text. These are actually human readable, but if we do an encryption here, they will change. They will change to a string, to a random string of text, Mhm. Sorry. Let's see the seed phrase generator. Sometimes they are also referred to as mnemonic phrase word. So you can generate, like you can choose the words you want. If you are creating a wallet, the more the words you are using, the better the encryption. The same for like passwords. It's the same way password works. So if we generate, so this is the word, and this is the QR code of the private key. So these are the words. They are 12 words. And then we have the seed phrase in cryptography, or the encrypted words. And then this one is for Bitcoin. So if I change for Ethereum, then the seed word will change. The seed will also change. Like this one will change. Yeah. So this is how you do, or this is how these words are generated. Yeah. And since you are now for wallets, when it comes to development, you also need a way you can generate wallets. So Ethereum has a web3 web3.js. It's a library that you can also use to generate wallet. They are generally generated there. So we have web3.js address. So with Web3, this is a method that you can use to generate accounts. This one. So web3.eth.accounts.create. And then you combine it now with this. You tie it together with it so that that particular address is contained to, or is associated to that seed phrase. Yeah. So MetaMask uses the asymmetric for all the addresses. I think I did like I did the opposite, because sometimes these words are confusing. So symmetric key is normally used for password hashing, the general password hashing, because you need one password if you want to access your your home. You will use that one key to open and access all the room in your house, unless if you don't lock the other doors. But with that one key, you are able to open the door and also lock the door. But for wallets and addresses, they normally use asymmetric key. And for the entire blockchain, now the blockchain itself, it uses the two, asymmetric key cryptography and also the hash function. So I hope that one is clear.
Yes.
Yeah. Okay. So we can continue with the asymmetric key. So this okay, so yeah, so cryptocurrency are one of the major application of blockchains, and they use both public private key pairs to maintain the addresses of the user on the blockchain. So for cryptography in blockchain, the public key is used as the address of the person. So this one is used as the address of the person, the way you have your phone number. And then we have the public key is visible globally, so it is visible to any participant of the blockchain. And the private key is a secret value and is used to access that address data and authorize any of the actions of the address, which are generally transaction. So it's the same way you have your M-Pesa PIN or the mobile money transfer PIN that you normally use in your country. And it's your secret key. So the moment you share that seed phrase with anybody, people can be able to like access your account and also transfer your funds. So most of the attacks or most of the scammers normally use this way. Like they tell you that you have received an award, and they con you, telling you that you need to, these days they have actually advanced. They can create a wallet and tell you that you have received an award in this wallet. To claim your award, you need to like uh like add your address there and paste your wallet key. And also there is another version of MetaMask. So when you are creating, just make sure that you are using metamask.io, and then you check the wording of MetaMask wallet. You check the wordings of the MetaMask wallet. So a friend of mine actually sent me that MetaMask. So we had somebody who had created a fake browser extension like for phishing and stealing cryptocurrency wallet via the Google ads. And then there was another one. They had created a fake MetaMask wallet, and most people were vulnerable to these attacks. So yeah, you have to make sure that it's this one metamask.io, and then the words are spelled correct. So the devil is always on the details. Yeah, the devil is always on the details. So the A might be changed, like it's spelled like matter or make something. It might be changed. So yeah, so you have to be careful with your secret words. Then we have digital signatures are widely used for cryptocurrency. They are used to approve transaction by signing them securely offline, and are also used for multi-signature contracts and digital wallets on the blockchain. So to perform any action from these multi-signature contracts and digital wallet, the digital signature from multiple or different private keys are required before any action is to be executed. So that is all about cryptography and asymmetric key. Uh, yeah. So let's continue. So we have uh, so as I have said, blockchain generally uses the secure hash 256 hashing algorithm as the hash function. And cryptography has hash functions provide the following benefits to the blockchain. So this is the type of or the benefit of cryptography. So we have one, the avalanche effect, and this is actually where avalanche blockchain got its name. So the avalanche effect is a slight change in that data can result in significantly different output. So I also, if you can remember, I said take a look at the, or take notes of on on this H. So let's change the H to something different, and then we might. So if you can take a look at this hash, now it has changed. It has 4 zeros, B sits A. But if you take a look at the other hash, it has an opposite, or it's different. Yeah, it has changed. It has, let me just do it up here so that we can be able to see the differences clearly. Yeah, so we will be able to see. So the first one is capital, and the first one is a small, and then the second one is capital H. Yeah. So you can see there is a big difference. There is a big difference between the hash, and that is what we call the avalanche effect. This is the avalanche effect. So with a small change, the blockchain can bring a big can bring an output that is different, a slight change. And that's why I said that the devil is always in the detail. So a slight change can result to a big difference in the output. Then we have uniqueness. So with cryptography, every input has a unique value. So you have seen that with a small h and a capital H, there is a different, and every input is unique. Yeah. So we have the other advantage, that is deterministic. So any input will always have the same output if passed through the hash function. So long as we have that that high with a capital H, the output will always be the same. The output will always be the same. The output will always be the same. It will never change. We have the quickness. The output can be generated in a very small amount of time. And then reverse engineering is not possible. So we cannot be able to like reverse engineer. But there are other, that is for hash function, but for algorithms like MD5 and the ones that are normally used in password or sites, the web 2 sites, basically some of the site uses not that secure not that secure cryptography method, and that's why most of the sites are able to be hacked. So we can generate the input, but having the output and the hash function, it's not possible to do that. So the hash function, or together with the asymmetric key, is a one-way thing that you cannot go back to reverse engineering the seed phrase. So if you take a look at these mnemonic phrases, if we try to copy this and reverse engineer this will take a lot of time, and it will take a lot of computing power to like reverse engineer. And that's how now blockchain is that's how blockchain is secure, because for you to do such a hack, it's very expensive to do such a hack. The only way that you can actually do an attack on blockchain is on wallets and smart contracts. But the blockchain itself, once you have created the hash, you will need the same amount of, not the same, but even extra amount of power to actually decode that hash or decrypt that hash to reverse engineer it. And that's why you find that even for quantum computing, because quantum computing also uses a lot of power, it's somehow also impossible to kind of do the same. Yeah. So those are the 5 benefits of cryptography. And so hash functions have a major role in linking the blockchain to one another, and also to maintain the integrity of the data stored inside each blockchain, inside each block. So any alternation in the block data can lead to inconsistency and break the blockchain, making it invalid. The requirement is achieved by the property of the hash function, and which is that we have said the avalanche effect. So according to this, if we make even a slight change in the input to the hash function, we will end up getting a totally unrelated output as compared to the original output. So we have also seen this is another example that I had actually created, and you can actually compare and see that this one is different with a slight different, maybe I think it was the space. I added a space in this one. I added a space in this one. So the output changed because even a space is a character in computer in computing. So if you have a space in your wording, make note of the spaces in your in your in your wording. So that's why most users sometimes they used to complain that their seed phrase are not actually working. But if they load the words without the noting the spaces, then definitely that's a different hash. Yeah. So you have to note. You have to be meticulous when you are copying your seed phrase. Yeah. And also note the wording that all the seed phrase actually start with there is no seed phrase that I've ever come across that starts with a capital letter or the words are all in caps. No, most of the seed phrase are always in small letters. So you have to take a note of that. Yeah, so that is it on cryptography and how it's used and the benefit of cryptography. So there are another in Ethereum. We have in Ethereum uses public key cryptography for same for also cryptocurrency. And yeah, so I'll discuss oh yeah, yeah. I was actually looking for. So we have other forms of cryptography that are used, or modern cryptographic function used in modern cryptography. So we have cryptography itself, and then we have trapdoor function, and then we have prime factorization, and then we have a discrete logarithm. Yes.
You're not sharing the screen for that.
This one is not on the screen. Uh,
Oh, okay.
yeah, this one is not in the screen. I'm just mentioning because I realized some of my notes are not. Some of my notes are in my phone, and others are in my drive. Yeah. So I think this one will cover them tomorrow. The 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 cryptographic trapdoor, prime factorization, discrete logarithm, and elliptic curve cryptography. So these are tools which are being cryptographic methods which are used in modern cryptography. So some of them are being used in robotics or in AI, and majority of them are being used. Others are being used in space programs, and yeah. So tomorrow I'll share those notes because some of them are in my phone. So I'll change them, and then we'll talk about this type of methods tomorrow. Yeah. So that's about that's it about cryptography. Yeah. So we have now uh so having understood what is cryptography and the use and the benefit of cryptography, we can now move to cryptocurrency wallet. And so a cryptocurrency wallet is an app that allows cryptocurrency users to store and retrieve their digital asset as with conventional currency. So you don't need a wallet to spend your cash, but it certainly helps to keep it all in one place. So cryptocurrency wallets are apps just like those you might learn on a smart phone on computer. If you prefer, the tactical experience of holding a wallet, you can also buy a physical device that lands a wallet. So that's some of the wallet. They are classified depending with how you can access them. So the first cryptocurrency wallet was introduced by Satoshi Nakamoto when he first released the Bitcoin protocol in 2009. Bitcoin is the most popular, widely used cryptocurrency, but other building upon its blockchain technologies have emerged, and any of them can be stored on a cryptocurrency wallet. Wallet can hold multiple cryptocurrencies. So mainly there are 5 different types of cryptocurrency wallet, and each offer different features and security levels to make sure they provide the safety of your Bitcoins and ETH and private keys. So the first 5 types of cryptocurrency wallet include mobile, desktop, paper, hardware, online, and mobile wallet. Okay, online and mobile wallet. So for today we will tackle the first one, which is online or web wallet, online or web wallet. And then we have offline wallets. Yeah. So the first one is an online wallet or web wallet. So online or web wallet are the wallets that allow users to access the wallet through a web browser. It is suggested never to store all your cryptocurrencies into these types of wallet. So both the online wallets and online exchanges are vulnerable to cyber threats and are attractive to hackers. So online wallets are the fastest way to complete transaction, and these wallets allow users to manage a significant number of cryptocurrency. So a good example of an online wallet is, or a web wallet, is MetaMask. So here we have MetaMask. And then we have another one. This one is Zero Wallet. It actually looks like MetaMask. And then we have the other one, which is the Binance Chain Wallet. So this is the Binance Chain Wallet. They are basically browser extension, and you can also have access to them via the respective through their respective their respective their respective their respective either scan or explorer, their respective either explorer. So you can view it here, like generally all the transactions that you have been able to make. So this one is the link bay either scan. Sorry. If you want to see the trying to view it on the under expanded view. So as you can see, this is the expanded view of MetaMask wallet. So you can see the tokens you hold. It has a wide range of tokens that you can be able to hold. And you can also view it on Etherscan. So this is the public address or the public address of my public address on Etherscan, and this the way that I'm able to manage my funds and my activities, the activities that I've been able to done. Yeah, and they also help in like signing the transaction. Yeah. So that is MetaMask, and there are others. There are others because Parity is also part of a browser. It's also a browser wallet. Yeah, and then we have wallets that are generally created by exchanges. So for those ones, I would actually say that most exchanges, especially the ones which are not decentralized, are prone to attacks because the private keys are generally managed by the creators or the owners of that wallet. And then from what we have seen with MetaMask, you need to authenticate or get to know the legit extension. The same case for the other one, like Binance Chain and also the Zero one. So you have to get them from their official website. Yeah. So they are easy to complete transaction, and also they have a wide range of use, unlike mobile wallets. Yeah. So if I have no notes there. So we have mobile wallets. Mobile wallets are the wallets that can be downloaded and installed into mobile devices. So these wallets allow users to access cryptocurrencies through mobile devices and carry out daily activities. These wallets are based on the internet, and therefore users must protect this from security risks. Users can quickly scan the QR code for mobile wallets and can make payments. So a good example of such wallet, and is Trust Wallet. I do Trust Wallet because they have a good developer community, and it was one of the wallets which was created. It has a multi sign, multi coin. It's a multi coin wallet. So if you create a wallet, it can hold this the if you create one wallet, that wallet is capable of holding different cryptocurrencies. So, and also you have an easy way of accessing your dApps, and you also have an easy access to access your decentralized exchange. And they offer different they have a community. You can join their community, you can get price alert. They offer different features, and yeah, you can also protect your wallet. You can also import your wallet. That is another feature they do offer. Yeah, so the advantage of mobile wallet is that, one, you are able to carry your device. You are able to carry your device, and since most users nowadays have a smartphone, you can be able to carry your device in different places. And when a need arises, you can be able to access your wallet and also be able to pay. Yeah. So that is it on wallets. And yeah, so tomorrow we will look at desktop wallets and paper wallets, and also hardware wallets. And yeah, and also we'll see the difference between hot wallet and cold wallet, and which one you can use, and depending with your need. If you want to access web-based dApps, if you want to access web-based dApps, you can use the web wallets or the browser extension wallet. If it's a place that accept Bitcoin payment or Ethereum payment or any other cryptocurrency payment, you can actually use your mobile wallet. If you want to secure your wallet, you can use a hardware wallet, and yeah, those are the portable devices, like uh, it's a physical device, so we'll see the difference. I know you have heard about Trezors. It was one of the hardware. It is an example of a hardware device. Yeah. So, in case you have a question or something you need clarified or a comment, you can ask. Hello.
Yeah.
Yeah. So if you have a comment, something you want clarified.
So, question.
Yeah.
Like in this type of crypto wallet, what would you advise a beginner or a fresher to have as a backup for their tokens? Is it the mobile or the desktop or the online wallet?
Okay. Okay. So as a beginner, what I would okay, I wouldn't want to. For me, what I've done, I'll actually use my case as an example. So for me, what I've done, I created multiple wallets on Ethereum, not on Ethereum but on MetaMask. So this one, this 0096 is a wallet that I normally use for most of my processes. So I have it on MetaMask, and I also have it on Trust. So I created it on in the beginning. I created a MetaMask wallet, and then I imported the wallet on Trust wallet, and the same for these others. That is Binance. I created one on Binance, and then I have imported it into my mobile app, into the mobile app, and then the same case for Zero wallet, which is this one. I also have a Varora wallet, which is the Varora wallet is a wallet that was created by Zero development team. So I normally create one here and I use it here. And then for exchanges, like for Rocco Cryptos, it's just, let me just log into Rocco Cryptos. Login, sign in. So for Rocco Cryptos, I have another wallet. But once I buy a coin on Rocco Cryptos, I immediately transfer that coin to my MetaMask wallet, because I have control of this wallet. Because this one is also decentralized. It has they normally don't store your password. They actually don't store your password. So it took me time to actually recover this account. I actually recovered the account this year. I recovered this account this year because I had lost my password. Yeah. So let me just verify my login. Let me just approve. So
Are you
if
sharing your screen?
yeah, oh no. Okay. So let me approve my login, and then we be able to. Yeah. So this is my local Ethereum or local cryptos. Initially it was called local Ethereum. So this is my local cryptos wallet, and this is my wallet. So you can actually see that they support for currently they are supporting 4 currencies. That is Ethereum, Bitcoin, and Dash and Litecoin. And they normally tell you that these are web wallet, which is an uncustodial wallet. So we have a custodial and non-custodial wallet. So non-custodial means that these don't own your private key. They don't manage your private key. And that is another thing that you also need to look at if you are also the wallet, the kind of wallet you are using. So if it's a custodial wallet, it means that these guys are actually managing your private key. So you are not secure, your funds are not secure in a custodial wallet. But if it's an uncustodial wallet, it means that they don't manage your private key. So if you lose your private key, then your money will be locked there, and they don't have, they won't be able to like withdraw your cash, and they won't be able. So it took me time actually to recover this account. It took me time to recover this account. I had actually lost my password.
You lost
So
it, and there's no way they can reset the password for you.
no, it's a one-way thing when it comes to local cryptos, all non-custodial wallets. They once the private key is generated, they don't.
Mm.
But for wallets, uh, depending on the architects of the system, this one like local cryptos, they don't store your information on a database because it's a decentralized exchange. But for exchanges like Binance, where you are doing a KYC and everything, they do have a separate system that interconnects with the blockchain. So let me show you back from our Miro. So in our Miro dashboard again, sorry, now Miro dashboard. Let me show you when you are creating a custodial wallet. There is a way that you are able to like so let me see if I have access to our previous board. Oh, nice, awesome. So we have too bad we don't have access to draw. Let's see if I can be able to create another board here. New. Oh, so normally in a normal system, this one is not good. Just use these stickers. So normally in a normal system, we have in a normal system we have the back end. We have the back end here with either non SQL or an SQL database with an SQL or a non database, which is used to retrieve this information. So which is used to retrieve this information, and this is the front end for UI or user interaction. So this is the front end. Yeah. So this database manages all the passwords, manages all the password, all the user information, all the all the details that you enter. And this is how the Web2 actually works. So data which is entered from frontend is stored there. But when it comes to blockchain, we don't have something like a database where we can retrieve this information. Data is distributed in the network. So when it comes to password, so this is blockchain. So when it comes to password or private key, using the asymmetric encryption or cryptography. So this one normally uses MD5 and another I can't remember the other hash, the other function for encrypting password. So these are passwords. So it uses the symmetric key. This one uses the asymmetric. So once the private key is encrypted, they themselves, they don't even have a way that they can be able to decrypt it. But for MD5, you can be able to decrypt it. So that is the password. So generally for this kind of system, for the exchange, then the exchange now gives you, if it's a system like Binance, so for you to access the exchange now here, you need to first of all go through this process, add your passwords and all the details, because something like the ID, they normally store the verification of ID. They normally store it on a database. They normally store those information on a database, and then they go all the way. Now after verifying your your ID and everything, and your user country, because most of these things have not been like recorded on the blockchain. Yeah, so they give you access to the blockchain now. But for something like local cryptos, the process is direct. They just give you, they just encrypt your password, the password that I've used. You are in charge of that password, and also you are also in charge of backing up your wallet. This wallet, so you have access to your, you can back up your wallet and save it on your desktop. And then this wallet, you can actually import it onto your browser. Yeah, you can import it onto your browser. You can import it into your browser, this wallet, so that you can easily manage your funds from here. Yeah. So depending with the architecture of the blockchain, some of the decentralized exchange have even gone a step further, where they don't actually store your, whereby they don't actually store your private key. They actually ask you to connect directly using your MetaMask wallet directly, like here, and they don't even have access to your wallet. They don't have access to your private key. I mean, they don't have access to your private key. So this one, you are in charge of your funds. So if you connect there, you are in charge of your funds. So this is the extra mile some of these decentralized exchanges have gone. And also here, if you go to the profile, you only need to like input your phone number and verify your email. That's all you need to do, so that you can start transacting on this platform. So you don't need a lot of things. You don't need a lot of verification in decentralized exchanges. Yeah, that's the beauty of decentralized exchanges. So you just need a phone number and verifying your email address, and that's all. And then you are in control. You can do whatever you want in this decentralized exchange. And again, you also have to remember that these are platforms that you are supposed to like share. You are supposed to like have good reputation on it. So such decentralized exchanges are actually based on the reputation of the users. So if a user has poor ratings, then you won't have good trades. People won't trade with you. So that's the beauty of decentralized exchanges, unlike centralized exchanges where they have custody of your private key. Yeah, but it also depends with the architects, because we might have centralized exchanges which are non-custodial, that they don't have access to your private key. Yeah. But once you buy your crypto, it's always good to like change it or save it on a wallet that you have control of, that you know that this wallet, I'm in control of it. Like MetaMask and Trust Wallet are good examples of wallets that you can have control. Yeah. So once I buy cryptos, I normally transfer them to MetaMask, because there I know they are safe, and I know no one has access to it. Yeah. And if I also buy from Binance, or if I buy from the other exchange that is Paxful, I will do the same. I normally the move the assets to a MetaMask that I do. And also, for if you're a developer, MetaMask is a good wallet for those who are into development, because it's offer a wide range of development settings. Yeah, so you can have advanced settings for creating. And they recently they launched a mobile version of the wallet. Yeah, so this one is for developers, so you can turn this one is for the IPFS gateway. And yeah, so depending with what you are doing, you can set them on, and you can change the network. You can also add different networks if you are a developer. Yeah. So MetaMask is easy for if you are a developer. Yeah. So that's about wallet. I've actually said a lot about wallets. I'm not sure what. Yeah. But yeah. Is there any other question?
Hello.
Yes. Hello.
I think I need a clarification. I don't really. I've seen the use case of I think it's asymmetric. That is like in the wallets, where you can have your wallet address is like your private public key,
Yeah.
and the back phrase is your private. The hash function, where exactly do we use? Where exactly is it used?
So the hash function is mainly used in smart contracts. So most of the smart contracts uses the hash function, and also the blockchain itself. I didn't have a good example for it, but the hash function is mainly used when you are hashing the blocks. When you are hashing the blocks, these ones, they normally use the hash function. This one, because this one is a bit longer. It has a longer characters than the private keys than the private key. So if you compare with private key generally has private key characters. It has 53 characters. It has 53 characters. So if you take a look at this one is a bit longer. Uh, this one is a bit longer. So this one is more than 53. If you like calculate these characters, they are more than 56. That is 4. So 4. So the 4. The 4. The 4. So if you calculate it, if you calculate these characters, they will be more than 56, and that's how you actually know the differences. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 16. So 16 by 4. So they are 64 characters. Yeah. So you see the longer the hash, the more secure it is. So the hash function is actually used in hashing the blocks, and then for things like MD5, they have MD5 have 12 characters, so that makes it even more easy to like crack. You can write a simple script, and then you are able to crack that encryption. So yeah, that's the use of the hash function. Yeah, yeah. I'll also come up. I'll also give more detail, because I some of my notes are in my phone. I had downloaded. I had some notes on my phone. I hadn't transferred them on my machine. So yeah, tomorrow I'll download them, which are more detailed, and then I'll share them with you also. Yeah, yeah. I hope that was clear. Yeah,
Okay, that's okay. And okay, so that means the hash function is mainly used in smart contracts and maybe a block, identifying a block.
yeah, yeah, yeah,
Okay.
yeah.
And okay, concerning wallets, uh, this is like my personal opinion. I feel like you choose wallet depending on the use you're having. Because
Yeah. Uh-huh.
if you want to trade on an personally, I'm a P2P trader on Paxful.
Mhm.
So I go to I if I want to sell and buy BTC, that's peer-to-peer trading. I have to choose like a wallet that supports that. If I go and deposit on MetaMask, I feel like um it's invalid because I cannot buy and sell on MetaMask.
Yeah, yeah, yeah. It basically depends with what you are doing. That's why I didn't want like to uh, uh yeah, it's actually depend with what you are doing. And I've actually mentioned that if you're a developer, you opt to choose a different wallet that supports your development. Yeah. If you're a trader, you will also use a different wallet, and especially if you're in Binance, you will use the Binance Smart Chain wallet. Yeah. So Yeah, that's correct. That is correct. That is correct. It will be depend with the use. Yeah, that is correct. Yeah. So if you Ambrose, you are looking to maybe invest or something, that's something. Yes. Your hand is on up. Damaris.
Uh, I had forgotten to lower my hand.
Oh, okay, okay, okay. Yeah. So yeah. Depending with what you do, you will use a different wallet. So if you want to connect to Uniswap, you will use a different wallet. If you want to do the same, you will use a different wallet. Yeah. So thank you for your questions and also contribution. Yeah. Uh, yeah. Uh, Something you want to say, Ambrose?
No, 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 no. It's okay. Thank
Okay.
you.
Okay.
Yeah.
Yeah. Thank you for your contribution and also your participation. Yeah.
It's okay. Thank you very much for sharing too.
Yeah. So
Thanks.
yeah, this has been an awesome class today, and yeah, let's keep it that way. Yeah. So
It's okay. Thank you.
yeah. So have a good night and yeah, enjoy the rest of your evening. Bye.
And you too. Thank you. Bye.
Yes, Amaris.
I was saying good night too.
Okay, good night.